Hello again. We are continuing our discussion of Algebra 1 by talking about functions and what the difference is between a relation and a function, how to tell if something is a function or not. So let's talk about that. What is a function? In general, it is a relation, so we've talked about what those are, but specifically, a function has every element of the domain paired with exactly one element of the range. So in other words, every x can only have one y associated with it. It's okay if different x's have the same y, but the same x can't have two different y's. So that's what we're looking for when we're trying to figure out whether something is a function or not. We're looking for a repeated x, not a repeated y. So if I'm looking at ordered pairs and I look at the green ones, all of those x's are different. But if I look at the red ordered pairs, I see that an x of 3 is used twice. So that second one is not a function because the same x goes with two different y's, and that can't happen with a function. It's still a relation, it's just not a function. So if I look at some tables, I'm looking for the same thing. I'm only looking in the x column to see if there's any repeats of any x's. So in the green table, all of those x's are different, so we're fine. But in the red table, I see that x of -1 shows up twice. So that table does not represent a function. It does represent a relation, just not a function. When I'm looking at graphs, it's kind of hard to tell, but there's something called a vertical line test. And that will help you figure out whether a graph is the graph of a function or not. So basically, I need to be able to draw a vertical line anywhere on the graph and have it only go through the graph at most once. So if you look at the green graph, no matter where I draw a straight up and down line, it's only going to cross the graph once. But if I look at the red graph, for example, if I draw a vertical line here, it passes through the graph 3 times, which is way more than once, so I know that the graph, the red graph, does not represent a function at all. And then finally, mapping, what we're looking for is we're looking for an x that has 2 arrows leaving it and going to 2 different y's. So if you look at the green mapping, all of those x's have 1 arrow leaving and going to a different y. It's okay if 2 of them went to the same y, but we can't have 2 arrows leaving the same x. So if you look at the red mapping, you'll see that that 6 has 2 arrows leaving it and going to 2 different y's. And that means that the second mapping, the red one, is not a function, the green one is. So let's talk about a few definitions before we continue. We have what's called discrete functions. And discrete functions basically consist of points that are not connected. And then continuous means that we are going to connect those points, and it's like a line or it's a smooth curve. So that's the difference between discrete and continuous. The vertical line test is that thing that I mentioned before for graphs, and that's a test that's going to help me figure out whether a graph represents a function or not. If it passes through exactly once, no matter where I put it, then it is a function, but if it ever passes through the graph more than once, it is not a function. Okay, nonlinear just means it's a function, but it's not a line. So it's a curve or something like that, but it's just not a straight line. Okay. Now, we have to talk about function notation. We've talked about x's and y's and how we can write things in y equals something with x in it. Another notation for a function is by using f of x instead of y. F of x is how I say f followed by x in parentheses. So that very last part I would say as f of x equals 2x plus 1. That's how I would say it. Okay, and it replaces y. It means the same thing as y. So what I can do is, if that x that's in parentheses is replaced with a number, then I look to the right-hand side of the equal sign and I replace every x with that number that's in parentheses. Let me show you how that works. So if I had f of x equals 2x plus 1, which I've already talked about up above, now I want to know what f of 5 is. So what I do is, instead of writing 2x plus 1, I write 2 times 5 plus 1, and that equals 11. Similarly, I could talk about f of -3, same function, but a different x. So instead of writing 2x plus 1, I write 2 times -3 plus 1, and that gives me -5. And finally, if I have f of 0, that means instead of writing 2x plus 1, I write 2 times 0 plus 1, and that equals 1. So now let's talk about if I have more than one function, because in any situation, you've got more than one kind of mathematical thing going on at the same time. So you could have a question that refers to two or more functions, so you need a different letter to define each one. F is just the letter that normally represents functions when you're talking about functions. F of x is a function. But you can't have multiple functions all being represented by f of x. So you need different letters if they're in the same question. So most people start with f of x for the first one and then move on to g of x for the second one and h of x if there's a third one. So I have three different functions, f of x, g of x, and h of x, and they all do different things. So I'm going to need to know what function I'm working with as well as what x is being replaced with. So for example, if I wanted f of 3, I have to look at the f function, and instead of writing x squared plus 1, I have to write 3 squared plus 1, and that gives me 10. G of 4 means I have to use the g function and replace x with 4, so instead of 3x plus 7, it's 3 times 4 plus 7, and that equals 19. And finally, if I wanted h of 6, I would have to use the h function and replace x with 6. So instead of 10 minus x, it is 10 minus 6, and that is equal to 4. So that's kind of a brief discussion on functions, how some relations are functions and some are not, and how to plug in numbers into functions, as well as talking about the function notation itself. So if you have any questions, please let me know, and I will see you tomorrow.